Hey, this is Professor Snell talking to Environmental Systems 2. I just did a video about exercise 7 where we, in this crazy little, uh, this drawing is an outline of what we did. We came up with a system sizing based on our load and the amount of energy we could create on our roof. I want to come at it from a different direction because it's also a typical way of doing it, and it's why I brought up PV watts in class. So let's play around a little bit here. If I go into just any browser and I say PV panels, you'll get a huge number of PV panels to choose from that you could, study and look at. Let's look at two different ones. Here's one that's rated at 540 watts. What does that mean? First of all, that's peak output. Probably says that here. 540 P max. So what we're saying is that this panel produces 540 watts at the peak conditions. So we don't know how much it's actually going to produce on our location. We don't know how much energy is going to hit that panel, because based on our location and our climate and our context, different amounts will hit it. But this is how we compare panels. So it's 540 watts per panel. And let's just check something out and remember it. So the panel is 90 by 45 inches. So 90 times 45, 4,050 square inches. If we divide by 144, that'll give us square feet. So we have about 28 square feet of panel, and it's rated at 540 watts. So 540 divided by 28 will give us, that's the number of watts per square foot, about 20. Let's just remember that, 20 watts per square foot. This isn't really a typical panel. A lot of times you see these 200 watts. They're sort of more the dimensions that we're used to if you just look at a lot of PV panels. So let's just look at this one and see what it puts out. So it's 200 watts peak. It is 65 by 24. So let's do that. A little more than 5 feet. So 65 times 20, actually was it 24? 26. Oops. 65 times 26. That is wrong. Starting again, 65 times 26 equals 1690 square inches divided by 144. It's about 12 square feet. So, and then if it's 200 watts divided by 12 square feet, it's a little lower, 17. But, we're in the ballpark. The other one was 19, really, I think. 19 something. This is 16 something. So that other panel seems like it was a little more efficient. But anyway, so 20, 17 is what we're looking at. So if we go back and look at, what we came up with for Phoenix was 40 kilowatt hours per square foot per year. So we're well below that now, but we haven't actually figured out how much this panel would produce on the site. So let's go there. We're going to do that by using PV watts, that program I showed you in class. So PV watts. It's a U.S. government, it's a National Renewable Energy Laboratory government program. It's pretty cool. If I put in Phoenix into my location, it finds climate data immediately. And so I say, go to create a system. It's asking me what system I want to, because what this is going to do is tell me if I give it the definition of a system, it's going to tell me how much power it will actually produce on my site. And so the typical system that you start off with in these kind of programs is 4 kilowatt hours, 4 kW, because that's just, I think that for a house, that's like a standard that people buy. I don't know exactly why we're using that, but it doesn't matter, because let's go back to our, so we were saying here that this system is so if this is a 200 watt panel and we want 4,000 we want 4 kilowatts, 4,000 kilowatts divided by 200 watts. That's going to be 20 panels. These are like essentially 5 by 2. So if I were to come back here and say, I'm just trying to figure out this, what this means. We've got, so we have a 5 foot by 2 foot panel here. Let's say we're going to do two rows. So this is 2 foot, this is 5 foot. If we did, and we need 20 to get our 4 kilowatts. So if we did 20 along here, so 10, I'm not doing this to code, to scale. So let's say that's 20 panels, right? It's going to be 2 times 10 is 20 square feet, and then 10 here, because it's just too wide. So 10 times 20 is 200 square feet. Yeah, that's almost no, compared to what we were talking about before. This is more like for a house. That's almost nothing. So we can definitely fit it on our roof. So let's go back to PV watts. It's saying, so that's just giving us some ideas. Pretty small system, 200 square feet. Let's see how much power it produces in Phoenix. It's saying then that 4 kilowatt system is going to make 7,000 kilowatt hours per year in Phoenix. So what's that going to mean in terms of how? Let's compare that to what we did in our previous calculations. So we were saying we had this 200 square foot system, right? And it is producing about 7,000 kilowatts in Phoenix. So I'm going to divide that by 200. Get about 35 kilowatt hours per square foot, and what we used was 40. So that's pretty close. So going from just like a commercial, what did we do? We went and said, okay, I'm picking one of these systems here. I'm going to go to PV watts, say if it's a certain size, how big is it? It's 4 kilowatts, which we figured out would be 200 square feet. We got the 7,000, and we came up with a very similar number to what we did for our going the other direction, where we actually went and looked at Climate Studio. So that's feeling pretty good, in terms of approaching this from 2 different directions and getting similar answers. Now, why did I go and look at these 2 different panels? All I was doing there was showing us, and what we did is we said this one was around 19, I think. The output, the pure output, was about 19 watts per square foot, and this one was about 17 or 16. It was 17 and 20, I think, showing us that, so these are different panels by different companies that have different sizes. But if you go look, and so they're going to have, they're going to have different, this one's claiming up to 25% production. I think the other one's more around 20. So it kind of makes sense that we were getting a slightly different number. But what I'm saying is, if you go and you look at a ton of different panels and you compare and you contrast and you spend tons of time on it, you're going to find that they're pretty similar in their outputs. Again, it's completely generalization, but that's why this approach works fine. And what this allows us to do is to use something like Climate Studio and schematic design to quickly calculate what we think would be an amount of PV solar electric we could collect on our site. And by the way, as you learn more about Climate Studio and how it works with Rhino, we can use Grasshopper, and there are things coming from the people who are doing Climate Studio, or we can make them ourselves, to calculate this for us. And so it could be in a parametric, we could create parametric objects in Grasshopper that then allow us to easily adjust the size of the system and see how much we're going to produce, etc. So I'm just arguing again that it's a good idea to, if you're interested in these things and want to be a little bit more technical in your architectural approach, keep your eye on Climate Studio. Keep trying to use it because it's very helpful in going to the next level. All right, that's it for this second angle on how to do assignment 7.